To run operations at scale, autonomous AI systems must rely on mathematical certainty, not probability. Feeding proprietary code into a language model, hoping the engine retrieves the right context, isn't an option. The core bottleneck preventing enterprise AI from safely scaling is the retrieval architecture itself. Traditional vector RAG systems operate by retrieving information based on statistical probability, rather than hard logic. This 3D representation illustrates a standard vector space model. When a query enters the system, it floats near a cluster of embedded data points. The engine pulls in surrounding nodes purely on spatial proximity, making a similarity guess, dragging in relevant context alongside irrelevant noise. In a strictly regulated environment, this architecture creates severe operational risks. A system relying on proximity guessing inherently hallucinates data, and worse, risks cross-tenant conceptual bleeding across isolated databases. To compensate for this inaccuracy, engineering teams are forced to expand their token context windows to an average of 12,000 tokens per query. They spend massive amounts of compute just to catch the necessary data buried inside the noise. True enterprise AI scaling requires abandoning statistical probability completely. It demands a system built entirely on mathematical determinism. This is FastStudio's Topology RAG. It is the first compliance-hardened, multi-tenant AI engine engineered specifically to solve the retrieval flaw. We need to examine how graph topology replaces vector memory, look at the verified performance benchmarks, and see how a real-time SecOps proxy layer enforces architectural compliance at the atomic level. As long as memory retrieval operates as a statistical guessing game, autonomous AI will function as a security liability rather than a reliable enterprise asset. FastMemory utilizes a custom Rust-native topology engine. Instead of plotting data in a latent vector space, it constructs rigid, logical graph structures directly from your existing repositories. This visualization demonstrates Louvain community network clustering. As raw codebase streams into the engine, the system automatically detects implicit functional boundaries, self-organizing the text into tightly bounded functional clusters. The engine maps this topology atomically. It structures the data through a strict hierarchy, moving from the high-level component layer down to the block layer and finally into the specific function. When an AI agent queries this engine, it does not conduct a search. It traverses deterministic subtrees on a mathematically rigid path, locking on to the exact terminal node it needs, like this specific crypto UUID function. Unlike vector engines that pull overlapping adjacent data, this explicit path acquisition structurally isolates information, completely eliminating the risk of cross-tenant data bleeding. The resulting output relies on precise, logical context. When restricted to a verified hierarchical path, the structural boundaries prevent the model from drifting into statistical hallucinations. Achieving this level of structural mapping through traditional ETL pipeline processing typically takes enterprise data teams weeks of execution time. By transitioning from probabilistic search to deterministic targeting, organizations guarantee their generative AI outputs are built strictly on verified, auditable logic. The first major operational advantage of Topology RAG is its ingestion velocity. Looking at this throughput comparison for a 100 gigabyte corpus, legacy systems like Pinecone and LangChain process roughly 0.8 gigabytes per hour. FastMemory's Rust-native engine indexes the same data at 100 gigabytes per hour, turning weeks of pipeline execution into a single afternoon. But rapid ingestion yields no value if the resulting queries remain slow and expensive to execute. Because Topology RAG retrieves exact nodes instead of broad clusters, the required token count drops drastically. FastStudio requires only about 800 tokens per query, compared to the 12,000 required by legacy systems. This efficiency drives cold start latency down to 12 milliseconds and cuts average monthly platform costs from $2,500 down to $267. Operating at a fraction of the cost usually implies a trade-off in accuracy. This data grid displays FastMemory's performance across 30 state-of-the-art AI retrieval benchmarks, independently verified. It hits 94.7% on Finance Bench, 97.3% on T2 RAG Bench, and 96.8% on MTEB Retrieval. FastStudio systematically outperforms every tested vector RAG system across both complex text evaluation and rigid coding environments. Ultimately, Topology RAG operates as an empirically proven architecture that finally brings predictable, scalable economics to enterprise AI. Flawless memory retrieval is only half the equation. If the agentic actions executing those queries remain unsecured, the network is exposed. Operating large language models inside restricted architectures, like defense, banking, and healthcare, presents massive compliance hurdles that require endless manual auditing. To secure this workflow, FastStudio utilizes a deeply integrated ActiveX layer. This schematic shows a zero-trust structural proxy sitting directly between the AI agent and the system infrastructure, filtering all streams through two distinct engines. The first engine is build-right. It validates every agentic action in real time against over 2,000 compliance frameworks, generating instant, legally auditable reporting for strict standards like SOC 2, HIPAA, and FedRAMP. The second engine is safe semantics. This security spine enforces over 5,000 SecOps rules to filter out prompt injection semantics, audit supply chains, and lock down potential data exfiltration routes. Both engines continuously scan all inbound agent queries and outbound code modifications dynamically, intercepting requests before any change touches production. Compliance and security move from being slow post-execution audits to active pre-flight architectural boundaries. FastStudio's rule sets actively interrupt violations the moment they occur. A security log identifies a risk after the fact. This system executes a block before the instruction reaches the infrastructure. Looking at the FastStudio enforcement console during live agent operations shows exactly how this interception works in practice. Here, a standard baseline interaction from an agent passes SOC 2 and HIPAA compliance checks flawlessly, and the output is securely delivered to the pipeline. But watch the log when an inbound request from Agent 12 attempts a prompt injection, sending a payload instructing the system to ignore its previous instructions. Operating on a strict 12-millisecond service level agreement, the safe semantics proxy identifies the malicious pattern and immediately blocks the transaction. The compliance engine behaves with the same exact rigidity. When Agent 3 attempts an unauthorized cross-region transfer of personally identifiable information, the system detects a GDPR data residency violation. The engine triggers an atomic rollback. The attempted transaction is instantly reversed. The event is securely logged to the compliance ledger, and critical alerts are automatically escalated to the security team. Implementing a rigid 12-millisecond interception SLA effectively transitions large language models from unpredictable black boxes into strictly governed enterprise engines. Securing an isolated AI tenant is essential, but it still has to interface cleanly with your existing engineering infrastructure. FastStudio deploys across 4 primary modes. Teams can utilize standard REST APIs for full control, event-driven webhooks for instant pipeline alerting, and CLI tools for managing terminal workflows natively. It also features native Model Context Protocol server integration, allowing teams to connect agents like Claude, Copilot, or Gemini directly into verified memory topologies. This custom secure environment runs on mathematically predictable pricing structures with zero hidden usage fees. Scaling autonomous operations inside an enterprise requires exact deterministic cognition, predictable latency models, and an active SecOps proxy defense to protect the network. FastStudio is currently whitelisting enterprise tenants strictly within the defense, finance, and critical infrastructure sectors. By eliminating probability from the equation, FastStudio's memory and SecOps framework guarantees absolute architectural determinism, delivering strict security for the future of enterprise codebases.